In today's video, we will just look at one of the learning outcomes, which is learning outcome H, where we relate the loudness of a sound wave to its amplitude and its pitch to its frequency. Right? Now, this seems really straightforward, and you're right, it is. And yet, it is one of the most tested learning outcome that you can find both in MCQ and your written papers. So let's look a little bit more into this part, and let's give you some sample questions from past year papers. So what's interesting about this part is that everything we see on the left side is actually what we say from day-to-day life. What we see on the right side, these are the physics concepts which you have learned previously in the chapter, correct? And we know how to see this in graphs. So the idea is that using the graphs, how do you relate it to what we know in day-to-day speech concerning loudness and pitch, right? So let's try to put these into graphs and let's make sense of it. So let's say we are presented with this graph, this pressure time graph, and we say, hey, there are two waves represented here, the green color one and the yellow color one. So if I were to ask you, hey, could you tell me what's the difference between these two things, these two waveforms? You would say, it seems like they have the same frequency. Could you say they have the same wavelength? You can't really say that because it's a time graph, correct? So you say, same, looks like the same frequency. So you would say that since the frequencies are the same, right? Same number of complete cycles in a given amount of time, I can't really say that pitch is different. But the most obvious thing is that you would see that, right? The yellow graph has a much greater amplitude compared to the green graph. Now, how does it translate into real life? Because no one says the amplitude is greater. People talk about loudness and pitch, correct? So therefore, you would say that in this graph, the sound represented by this yellow waveform is louder than the one represented by the green waveform. So which one represents something which is louder? You would say, the yellow one, because why? Greater amplitude, right? Amplitude is the maximum displacement from the equilibrium rest position to either the crest or the trough, right? So in this case, I'll talk about the loudness. Why is it louder? Why is that softer? Talk about the amplitude. All right, so we've talked about the loudness. Let's talk a bit more about pitch. Now, it's easy to describe pitch using the voice. This is very low pitch. This is very high pitch. And please excuse me. So when you hear that, you can understand pitch, but how do you see that in a graph? All right. So when it comes to pitch, all right, I want you to remember that the higher the pitch, the higher the frequency. And since we said frequency is the number of complete cycles in 1 second, right? If I have a very high frequency, I'm going to see a lot of complete cycles. I'm going to see a lot of waves in that amount of time. So now I'm going to draw, again, two different waves on the same graph, and you're going to tell me based on the idea which is a high frequency or high pitch and which is lower pitch. All right, so the question is, based on these two graphs, which one shows a sound which has a higher pitch? You would think pitch means frequency, and higher pitch means higher frequencies, and higher frequency means more complete oscillations. So which has more complete oscillations? Red has 1.5, blue has 1, 2, 3. So therefore, the blue color one over here, this is the one with a higher pitch. Now, there's no point saying it's higher frequency. Tell me that it's a higher pitch because it has a higher frequency, right? Sounds good? So that means every time I look at it, as long as a higher frequency, that means, pitch is higher, right? But what if I don't give you one, which is a pressure time graph? What if it's a pressure distance graph? What would that look like? And does it still make sense? Because we all know that you can't get wavelength from a pressure time graph, correct? The moment you see time over here, that's about period, correct? So how does it relate to wavelength? So let's talk about that. Okay, let's do a very rough drawing. I'm very sure this is not the most accurate way of drawing it, but hey, this is one which shows distance. I should be talking about wavelength, correct? So can I still talk about this pitch when it's not a graph that tells me period? Well, let's put it this way, okay? Looking at this, right, I can see that for the black color one, correct, the number of oscillations is 1. But for the blue color one, the number of oscillations is 2. So yes, even though this over here is like that, I can still say, hey, wait a minute, I recognize that the blue over here is way more frequent, correct? So, hey, you know what? I can even tell just by looking, right? It is twice the frequency, correct? So if I know it's twice the frequency, then I also know it is twice the pitch. Wait, hang on. Is it a higher pitch or lower pitch? Is the blue one a higher pitch or lower pitch? You would say twice the frequency, higher pitch. Or you could say the black color line, right, represents a sound which is of a lower frequency because it has a lower. Hey, wait, that's it wrongly? Oh, I kind of did, right? The black color line represents one with a lower pitch because it has a lower frequency. All right, all good? Now, how does this come out in exams? What must you do? The most important thing that you will be expected to do is comparison. Questions will give you two different ways, and they're going to ask you to compare the amplitude and frequency and relate that to the loudness and pitch. Just remember what they're really asking you to do is, hey, over here, these are the physics concepts you know. Please put them to common knowledge, things which everybody talks about. But now you have the additional layer of information, which is, I can tell you why is louder, why is a higher pitch. Not just because it hurts my ears, but because I can talk about the amplitude and the frequency. So let's end off with a simple question, and then after that we'll end the lesson. So here the diagram shows two different sound waves, right? So the question asks you, I want you to describe the similarities and the differences between the two sound waves. So let's call this sound wave A and sound wave B. So what are the similarities you see? I can see that they kind of look like they end at the same place, correct? So I'll say that based on physics, based on using graphs, both of these have the same frequency, correct? Number of complete cycles, same frequency. So I know for similarity, you know what, I'm just going to pause it and write it down. Now isn't that so much better? But what's different about it is that, hey, even though they have the same frequency, this over here, this clearly has a much bigger or greater amplitude compared to the green graph, isn't it? So that means A has a greater amplitude. But I need to change the word amplitude, which is physics, to common knowledge. I would say that greater amplitude, that's louder. This one has a small amplitude, this is quieter or not as loud as A. So again, I want to emphasize that not are we just talking about the physics over here, it needs to translate into saying that, hey, frequency is the same, then these have the same pitch. Hey, the amplitude is different. A has a larger amplitude. A is louder. Is that all? No, it's a comparison. Louder than B because it has a larger amplitude. Or you could see that B has a small amplitude. This is basically how it looks like for the past about 9 minutes. These are the things you need to know. Okay? Rather simple here. I just realized there's a owl bird outside that's been making a sound all this entire time. I'm so sorry. Yes, did it again. Okay, I wanted to say one more thing. Just being able to recognize is not enough. Sometimes they are expecting you to draw the things also. Okay, so let's say for example, okay, just one last part. Shh, quiet, shut up. Okay, let's say I need to draw, hey, what if I have another instrument, all right? So I have another instrument that's going to play a sound, right, which is as loud as A, but it's of a lower pitch. How do I do that? Lower pitch means lower frequency, right? That means, how? Well, let's just use basic, okay? There's one complete oscillation here, correct? If I want to have a lower frequency, I need to have less number of complete cycles, correct? So maybe let's just draw half. I said it's the same loudness, so the amplitude must be the same. So I could draw something like this, right? So can you see that the amplitude roughly drawn over here? Please excuse my iPad skills. The amplitude should be the same, so same loudness. But hey, there's only half a complete cycle here. right? So definitely this is going to be a lower pitch. So this red color line, this instrument would have a lower pitch but same amplitude. Can you tell that that owl bird, right, is getting louder and his pitch is going higher? Wow, that is irritating. But now you know that when it's louder, right, the amplitude is greater. And when it's going a higher pitch, the frequency is getting also, it's increasing in its frequency. All right, that's all for me and the owl bird over there. Hope this helps. Bye.